Hello everyone, in this video I'm going to show how to do data inspection using R. So you see on the screen Balance Gig data. Balance Gig is a company that matches independent workers for short-term engagements with businesses in the construction, automotive and high-tech industries. The gig employees work only for a short period of time, often on a particular project or a specific task. A manager at this company extracts the employee data from their most recent work engagement, including hourly wage, as you see on the screen, industry, and the job. So the manager suspects the data about the gig employees are sometimes incomplete, perhaps due to the short engagement and the transient nature of employees. She would like to find out number of missing observations for hourly wage, for industry, and for job data. And she wants to know the number of employees who worked in automotive industry, the number of employees earned more than $30 per hour, the number of employees who worked in automotive industry and earned more than $30 per hour, and the hourly wage of lowest and highest paid employees at the company as a whole, and the hourly wage of lowest and highest paid accountants in automotive and the tech industries. So we are going to complete all these tasks using R. First thing, you need to save this data as CVS file. So choose Save As and then go to your R and start a new R script. We first need to set the directory for R. So click on Session and set Working Directory. Choose Directory. This should be the directory that you can find your data. And my data is on my desktop, R Videos folder. And then I set my directory, R Videos. Once I choose this directory, as you see, Gig CSV data shows under Files. So the first thing is we are going to import data and call this as my data. So you're typing on the script part, my data is equal to read.csv is the command, in the parentheses, gig.csv. And then to run this code, you just click on Control and Enter together. So now you see my data is already uploaded, 604 observations and 4 variables. Let's check our data, employee ID, hourly wage, industry and job. Second, we are going to use the dim function in R to count the number of observations and variables. So let's type dim, in the parentheses my data, and then Control Enter. You see on the console panel 604 observations and 4 columns we have in this data. Second, we are going to use 2 common functions to display a portion of data, which are head and view. The head function displays the first few observations in the data set. Let's type it, head, my data, and Control Enter. You see, we see the first 6 observations in our data set. And the view function, which is case sensitive, view, my data, Control Enter, will display the whole data set in an Excel sheet format. So R stores missing values as NA, and we use the is.na function to identify the observations with missing values. So is.na, my data, and Control Enter. So R labels observations with missing values as true and observations without missing values as false. In order to inspect the industry variable for missing values, we need to enter is.na, my data, but this time I'm referring to only one column, which is industry. So we use a $sign if you refer to a column in a data set. $, industry, and then enter. To inspect the 24th observation, we specify row 24 in the my data data frame. So we are going to enter my data, but this time square bracket, and then 24, comma, and then enter. Note that there are 2 elements within the square bracket separated by comma. The first element identifies a row number, also called the row index, and the second element after the comma identifies a column number, also called column index. Leaving the second element blank will display all the columns. To inspect an observation in row 24 and column 3, we are going to enter this one. 24, comma 3, and then Control Enter. So we don't have anything back because that is a missing value. In a small data set, we can also review the missing values by scrolling to the specific rows and columns in the data viewer produced by the view function. To identify and count the number of employees with multiple selection criteria, we use which and length function. So in the following command, I'm going to type length first, and then open the parentheses, and then type which, and then my data, and I'm going to choose the industry, but industry equals to automotive. First, I identify which employees work in the automotive industry with the which function and count the number of these employees using the length function. The double equal sign, also called equality operator, is used to check whether the industry is automotive. In R, text characters are written in quotation mark. You can also here, instead of equal sign, you can choose greater, smaller than equal to, greater than equal to, or not equal to. For not equal to, you choose an exclamation mark and an equal sign in R. Another thing we are going to do is we want to find out the number of employees who can earn more than $30 per hour. So we enter length and then open the parentheses, which my data, and then choose hourly wage, and then greater than $30. So we want to count the number of employees that are earning more than $30 and then enter. 536 employees are in fact earning more than $30 an hour. To count how many employees worked in a particular industry and earned more than a particular wage, we use the AND operator. So let's write the command length and then open the parentheses, which, and then my data. This time first we choose the industry. Industry needs to equal to automotive. For AND, we use this sign, and my data. This time I'm going to choose hourly wage, greater than 30. And then we enter. So we find out that 181 employees worked in the automotive industry and earned more than $30 per hour. Next, we use the order function to sort the observations of a variable. In order to sort hourly wage variable and store the order dataset in a new data frame, we need to identify a new data frame. Let's say sorted data 1 is equal to my data and square bracket order, open the parentheses, my data, and we choose the hourly wage. We use the order function to sort the observations of a variable. In order to sort the hourly wage variable and store the order dataset in a new data frame, we need to call a new data frame, which in this case I call it as sorted data 1, is equal to my data in the square bracket order, and then my data hourly wage column should be selected, and then comma. And after you complete this command, click on Control Enter. Sorted data will be shown under Environment pane. In order to see the sorted data, we will use View function. Sorted data 1, and then Control Enter. You see hourly wage, the minimum is 24.28. If you want to sort the data in a descending order, then we are going to type this command. So we are going to get this one, copy, and then paste it here. We need to add here, comma, decreasing is equal to true, and this time Control Enter. And if you view your sorted data, Control Enter, you will see that now the hourly wage starts with $51. To sort data by multiple variables, we specify the variables in the order function. The following command that I'm going to type is going to sort the data by industry, job classification, and hourly wage, all in ascending orders. And it's going to store the ordered data in a data frame called sorted data 2. So sorted data 2 is equal to my data, square bracket, my data, select industry, and then my data, select job, and my data, select hourly wage. This should be square bracket. Don't make the mistake that I do. But we forget here order. And close the parentheses and comma. Now it's ready, so we can run this command. And now we can view our sorted data 2. And then enter. So, lowest paid accountant who worked in the automotive industry made $28.74, as you see on the screen. To sort the data by industry and job classification in ascending order, and then by hourly wage in descending order, we insert a minus sign in front of the hourly wage. So we are going to copy paste this data, and the only thing we are going to do is put a negative sign in front of hourly wage, because we want hourly wage to be in descending order. Run this code again, and then again we can choose view sorted data 2, and then control enter. And now you will see here that the highest paid accountant in automotive industry is $49.32, as you see on the screen. The industry and job classification variables are non-numerical. As a result, to sort the data by industry in descending order and then by job classification and hourly wage in ascending order, we use xtfrm function with the minus sign in front of the industry variable. So let's call our data frame sorted data 3 is equal to my data, open the curly bracket, and then here order, and open the parentheses, negative xtfrm my data industry. That's because we want industry in descending order. And then next, comma, my data $, job, and comma, my data $, hourly wage. These are going to be ascending order. And then after the parentheses, we have a comma, and then control enter. Let's see our sorted data view. Sorted data 3, and then control enter. So the view function reveals that the lowest and highest paid accountant in the technology industry making $36.13 and $49.49 per hour respectively. To sort the data by industry, job, and hourly wage, all in descending order, we use the decreasing option in the order function. So let's do that. Let's say sorted data 4 is equal to my data order, and open the parentheses, my data, choose industry, comma, my data, choose job, comma, my data, choose hourly wage, and then decreasing is equal to true. And do not forget, after these parentheses you should have a comma to complete the command, and then control enter. And now we can view our sorted data 4. So finally we are going to export sorted data from the previous step as a comma separated value file. So we are going to use write.csv command, and then in the parentheses sorted data 4, and what we want the name to be sorted data 4.csv, and then control enter. Downloaded file is going to be here, you see, on your directory, sorted data 4. So that's all about how to use R to do data inspection. What we can do finally, we can save this code, save it here, data inspection. And then save it.